For the warm-up, number 1, we are asked to find the arc length of AB, and this requires us to set up two equal ratios. So first I'm going to highlight AB. I know if it has two letters, it should be less than 180, so this is arc AB. So let's go ahead and fill in our two equal ratios here. Arc measure is our first ratio. So the degrees of AB is 80, because it's the same as the central angle here, which is 80 degrees. So it's 80 degrees out of a total for a circle is always 360 degrees. And we're trying to find the arc length, which is a portion of the entire circumference. So that's our unknown. And the entire circumference of the circle is 2 pi r. So 2 pi, and then we're plugging in the radius, which it's given, it's 5. So from here, we're going to cross multiply. 360 times x is 360x, and that's equal to, we're going to be multiplying these four numbers together. Remember pi, we're going to use approximately 3.14. So I'm going to grab my calculator and multiply 80 times 2 times 3.14 times 5, and I get 2,512. One last step to isolate the x, we're going to divide both sides by 360. And again, we're rounding to the nearest tenth, so the length of AB is approximately, it's 6.97, so if you round that up, that would be 7, and the units is centimeters because the radius was in centimeters, so approximately 7 centimeters. For part 2 of the warm-up, the goal is to use the exact same method of creating a proportion to equal ratios. And in this case, instead of finding the arc length, which is a portion of the circumference, we're going to be finding a portion of the circle's area, which is called a sector. So this shaded piece here is called a sector. So it's a portion of the area circle. So we could use almost the same method as we did in the previous, except the second fraction, instead of circumference, now it's a portion of the entire area. So if I look up my setup, the first thing I need to do is find the arc measure. So AB is 120 degrees because it's the exact same as the central angle. So it's 120 out of a total of 360 for every circle. We're trying to find what portion, so x out of the entire area. So area has a formula. It's pi r squared, where r is the radius. And again, we're using 3.14 for pi. So it would be pi. The radius in this picture is 4. So pi 4 squared. So from here, we're going to be cross multiplying. So x times 360 is 360x, and that's equal to. So we're going to be multiplying 120 times 3.14 times 4 times 4. So 120 times 3.14, and I know 4 squared is 16. So I get 6,028.8. One last step, divide both sides by 360. And we're going to round to the nearest tenth. So if I divide this by 360, I get 16.7, and our units will be centimeters squared. How come it's squared in relation to the previous where it was just centimeters? The reason it's squared is because we're plugging in 4 centimeters times 4 centimeters, so it becomes centimeters squared. So for these next two examples, we're going to be finding the arc length, which again is a portion of the circumference, and then the area of the sector, which is a portion of the area. So the setups are almost identical. In fact, the first fraction will be exactly the same for both proportions. However, the second fraction is a little different because this first one, arc length, the second fraction is going to be talking about circumference, and then the second fraction will be talking about area. All right, so if I look at this picture, I need to find the degrees of the arc. So 60 degrees is the measure of the arc because it's exactly the same as the central angle. So 60 out of a total of 360. And then the arc length, we're trying to measure from here to here. So that's our unknown, and that's out of a total circumference of, remember, circumference is 2 pi r. So 2 pi, and then the radius is 10. So we're ready to cross multiply. We're going to round to the nearest tenth in the very last step. So 360 times x is 360x, and that's equal to, we're going to be multiplying these four numbers together, and of course you could always multiply them quicker than doing all four separate. So 60 times 2 times 3.14 times 10 is 3,768. One last step to isolate. We're going to divide both sides by 360 and round to the nearest tenth. So if I divide this by 360, I get approximately 10.5, and the units is inches. So approximately 10.5 inches is the arc length. Shifting over to the area of the sector. So if I shade this piece in, this is the sector we're looking at. So again, the first fraction is identical. It's 60 degrees out of 360. We're trying to find what portion of the area, so x out of the total area of a circle. So remember, area of a circle has a formula, pi r squared. So I'm plugging in pi, the radius is 10, and then I'm squaring that. So cross multiply. X times 360 is 360x, and that's equal to, so I'm multiplying 60 times 3.14 times 10 times 10, or it's the same as 100, right? If you square 10. So 60 times 3.14 times 10 times 10, and I get 18,840. One last step, divide both sides by 360 and then round to the nearest tenth. So if I divide by 360, I get approximately 52.3. The units is inches squared. So remember, area is always units squared, and then the arc length is just the units, inches. All right, moving on to this next picture. So we're trying to find the arc length from here to here. So how many degrees is the arc? It's 150, the same as the central angle, out of a total of 360. What portion of the circumference out of the entire circumference of a circle, which has a formula, 2 pi times the radius, our radius is 3. So cross multiply. X times 360 is 360x, and that's equal to, I'm going to have to multiply 150 times 2 times 3.14 times 3. So 150 times 2 times 3.14 times 3, 2,826. And if we divide both sides by 360, I get approximately 7.9. So 7.9 meters is our units there. So for the area of the sector, this shaded piece here, a portion of the entire area, the degrees is the same. It's 150 out of a total of 360. What portion, x, out of the entire area of a circle? So pi times the radius squared. So we're plugging in 3 for the radius and then squaring that. So cross multiply. 360 times x is 360x, and that's equal to, I'm going to multiply 150 times 3.14 times 3 times 3. And I get 4,239. One last step, divide both sides by 360. And I get approximately 11.8 meters squared. For this last example, we're going to be comparing two different sprinklers in the area of grass that they water. Technically, we need a ruler, a compass, and a protractor. The ruler is used to measure the radius, the compass is used to make a circle, and then the protractor is used to measure the degrees, but we're going to try to kind of freehand this. I do have a ruler here. So the very first sprinkler has a 3-foot radius. So I'm not going to be able to draw 3 feet on this paper, so we're going to scale it down. So I'm going to say 1 foot is 1 centimeter. So if I need 3 feet, that would be 3 centimeters. So I'm going to make this point my center of the circle that I'm going to be drawing. And I'm going to measure with the ruler 3 centimeters, which would be right here. and then I will connect that. Next, I would take a protractor and measure 140 degrees. So in this case, I'm just gonna freehand it. So I'm gonna say this would be 140 degree turn right here. From there, you would measure the 3 centimeters again to connect here. And then lastly, you would take your compass, which makes circles, and then you would draw your arc there. So this is how much that first sprinkler covers. The second one has a 4-foot radius. So I'm going to draw my center here. I'm going to use my ruler. So 4 feet would be 4 centimeters for our scaled version. So here's 4 centimeters. 100 degree turn. So again, using a protractor to make a 100 degree turn, I will say 100 degrees is right here. Your radius will still be 4 centimeters, and then you can use your compass to make a circle. All right, so this is the shaded piece of that first sprinkler, so sprinkler A, and this is how much it covers on the grass, sprinkler B. So we're going to be proving which one has a greater area that is covered. Right now it looks like sprinkler B looks larger, and we can prove that by finding the area of each sector. So we have a proportion to set up. The very first proportion is talking about the arc measure. So this was a 140 degree turn, so it's 140 out of a total of 360. What portion X of the entire area? Area has a formula. It's pi r squared. So the radius in this case is 3. So from here, we're just cross multiplying in order to solve for X. So 360X is 360X, and I have to multiply 140 times 3.14 times 3 times 3. So I get 3,956.4. One last step, divide both sides by 360, round to the nearest tenth. So I get approximately, it's 10.99, so that rounds up to 11. And our units would be feet. So the total area, approximately 11 feet. For the second sprinkler, we're going to set up our 2 equal ratios to find the area of the sector. So this one was a 100 degree turn, so it's 100 out of a total of 360. What portion of the entire area circle do we have? So X out of pi, the radius in this case is 4, so pi 4 squared. Cross multiplying, 360 times X is 360X, and that's equal to, I have to multiply 100 times 3.14 times 4 times 4, so that's 5,024. One last step, divide both sides by 360, round to the nearest tenth. So if I divide by 360, I get 13.95, which rounds up to 14 feet. So which sprinkler covered the larger area? That would be sprinkler B.